Rachel, you might be wondering why all these theorems, why all these things about, theorems, why another theorem, why do we need it? Well, this example is going to show you one of the reasons, one of the usefulness of this particular theorem about similar triangles in the particular situation that we have been talking about, which is when you have a right angle triangle and then you have an altitude drawn from one vertex of that initial rectangle triangle onto the hypotenuse of that original triangle. Okay, here's a swimming pool example. It's in your book. It's on page 450. It's an example in your book, and it's a swimming pool. This is the base, but then it dips over here, so you have a deeper section of it. So they give you some dimensions from here to here: 165 inches, 152 inches, 64 inches, 48 inches up to here, and they're asking you, what is this? What is the deepest depth? What is the depth of the pool at its deepest point? The deepest point is, of course, point T, here, right here. But they give you from here to here, so all you need to find now is from here to here. So the segment MT, which we have labeled H in this diagram. Now, let's see how we can use the things that you have learned so far. First of all, what we have to do is to identify the similar triangles in this picture based on what we have learned so far. So that your original triangle is this one, and that's the one I've drawn here, RST. Okay, you draw it in a way, you want to orient all the triangles the same way. That way all the segments that are the ratios of the segment will be easier for you to identify. So we position all the right angles here on our right, make the short leg, the vertical leg, the short leg in each triangle. So in the case of the original triangle, the short leg is ST, so we make that here. In the case of the smaller of the two new triangles, the short leg is SM. Okay, so it will be here, but you know that the right angle is M for that triangle. The right angle is at point M, that's why you put the M down here, but you know that the short leg is S. So once you fix those two, it's easier to draw the third one, and you know it to be T, because that's the triangle right here, the one that I shaded in green here. And then the third one, dotted red here, the right angle is also at M, and then the short leg is TM, right there, and then the hypotenuse, of course, is TR. Okay, so now once you have those three triangles, it's easy for us to write that triangle RTS is similar, not congruent, similar to triangle TMS, and it's similar to triangle RMT. That's not the only way we could write it. We could also go RST, that is this way first instead of this way first. RST must be similar to TSM, and that must be similar to RTM. So then, what are they asking you to find? They're asking you to find MT or TM. So let's look. So for example, the TM they're asking you to find is this thing right here. Okay, out of RTM, it's this one. Okay, so let's look. So we know that we have ST, which is a relative. So you have to look in the diagram that you are given, which dimensions are you given? Okay, we're given ST, so that's that one, which occupies the same position as TM in the in the small one versus the big one, okay? And then, do we know RS? RS, we know 165, so we know this one. Do we know RT, which occupies the same position? RT we also know. So in fact, now we can build a ratio, because RS over RT, RS over RT is the same, must have the same ratio as ST, right here, over TM, right there. So the only thing we don't know so far is TM in this equation. We know that, we know that, we know that, because we're given. So then you form that ratio. 160, you plug in the numbers, and the only thing you don't know is the TM, which is H, and then you can solve this ratio, okay? And that gives you H, and once you obtain H, you add it to 48 inches, and that will give you your final answer, which is the total depth, the maximum depth of the pool, okay?